Let's look at question number 3. It says a girl wears a high-heeled shoe whose heel is 1 centimeter squared in area. So they've already given us the area of the shoe. If she stood on one leg, calculate the pressure she exerts on the floor if she weighs 400 newtons. You see? So the girl wears a high-heeled shoe. And we all know that this girl has 2 legs, but we are told that she is standing. She stood on one leg. And I've given us the area of the heel, the area of the shoe, which is touching the ground. So we are supposed to calculate the pressure she exerts on the floor. And we are given the weight of the girl as 400 newtons. So 4 marks. So we shall come here and write our solution as a subheading. And then we put the information the examiner has given us. The force is given as 400 newtons. That is the weight. The area of the shoe touching the ground, the heel, that is a high-heeled shoe, is 1 centimeter squared. Now you realize that the SI unit of force is newtons, but the SI unit of area is not centimeter squared, but meter squared. So what should we do? We must convert, we must change centimeter squared into meter squared. To convert is to change. There are some people who convert from one religion to another every week. Today is a Muslim. After 2 weeks or 1 month, he becomes a Catholic. After another 2 weeks, he becomes a what? A born-again Christian. They keep on changing. From there, they go for Buddhism and so on. So here I'm using that example to explain to you what they mean by converting. When we say convert, we mean to change. So this area is in centimeter squared, but the SI unit of area is not centimeter squared, but meter squared. So what do? We are supposed to change this centimeter squared into meters squared. You see, that's why I'll put this information, this red part, that you are supposed to change this into that. Now, for you to change units from one to another, you must know which one is bigger. According to our metric table, the metric system, which we must have learned right from primary, our primary schools. When you look at a centimeter, before you square this, I want you to look at this as a centimeter before you square and this as a meter. And ask yourself, a centimeter and a meter, which one is bigger? The meter is bigger. You see? That's why we say 1 meter, according to the metric system, is the same as 100 centimeters. You could as well say 100 centimeters is equal to 1 meter. You will still be correct. Now, to show that a meter is big, I want to give you a simple example. If you are one person and you are carrying a weight which 10 people can carry, who is stronger? It is you. Because you are only alone. You are one person, but you are carrying something which 10 people or 100 people are supposed to carry. So for that reason, the meter is bigger. The meter is 1, but the centimeters are 100. So 1 meter is the same as 100 centimeters. Now here the area has been given in squared form. So we are going to square this information. And squaring means we are going to square this side of the equal sign. We put everything in bracket and we square. Then also here, we put everything in brackets and we square. The square should be outside for all of this. Now, squaring here means we are going to handle them one by one. We are going to square 1. We square a meter. Then we come this side, we square 100. And we square centimeter. There are 4 things. There is 1, there is a meter, there is 100, there is centimeter. Each one you handle them separately. So let's begin here. Squaring 1 means you multiply 1 by itself, 1 by 1, and you get 1. Then the meter times a meter, you get meter squared. Then you cross this side of the equal sign. you handle 100 alone. 100 times 100, the calculator will say 10,000. Then centimeter times centimeter becomes centimeters squared. When you are squaring, you are multiplying that thing by itself, not by 2, by itself. So after squaring this side, we shall have 1 meter squared is equal to 10,000 centimeters squared. You see, that is according to the metric system. What about this area which they have just given us? 1 centimeter squared. We are supposed to convert it to meters squared. So where do we put? Do we put this side of the equal sign, or we put this side of the equal sign? Since these are centimeters squared, we put them where they are centimeters squared. Where are centimeters squared? This side we have meter squared, then this side we have centimeter squared. So we shall put it this side, so that the centimeter squared, they are on one side. Then this side, we shall call it x, because we are converting this to meter squared. But we don't know how many meters squared. When you change this to meter squared, how many meters squared make up this? So because we don't know the meter squared, which are corresponding to this, we shall call it x. Then after that, we cross multiply. Cross multiplying means 1 times 1, which you get 1. When you are cross multiplying, you ignore these what? Ignore these units first. Just multiply. Deal with the 1, 10,000 x, and then ignore this unit first. Ignore this unit and this one. Let's first deal with what is remaining. So 1 times 1, you get 1. X times 10,000, you get 10,000 what? X. Or you could as well say, put them in fraction form first. This one becomes a numerator, this a denominator. You say 1 over x equals to, there are two equal signs here, so you put 1. 1 over x. After combining them, use 1 equal sign. 1 divided by x equals to 10,000 divided by 1. And that's what I've done here. 1 divided by x equals 10,000 divided by 1. See? This one divided by x. Then this side, the numerator is what? 10,000. The denominator is x. Then you can now cross multiply. If you see that, possibly it was going to confuse you. Now, when you are cross multiplying, x multiplies the 10,000. You get 10,000 x. 1 multiplies 1, you get 1. Now, you are interested in x. So what do? You divide both sides by 10,000. So that 10,000 divided by this one cancels. So you divide here by 10,000, this also by 10,000. So when this one cancels, you remain with the x. Then here you'll have 1 divided by 10,000. And your calculator will give you 0.0001. So that is the value of the area. Now, what is the unit for x? You see, x is on the side of meter squared. This one is a centimeter squared. The unknown x is on the side of meter squared. So the unit for x should be the same as the unit for this one. The unit for this one, so there should be like, the units must be the same on both sides. So here our x is supposed to be meter squared. So what we have been doing here is changing the area from centimeter squared to meter squared. Now that we already know our area in meter squared, we can now calculate pressure. After all, we know the force. So our area is now this one. You don't use this one because you have already changed this one from centimeter squared to meter squared. So we shall now go ahead and say our pressure equals to force divided by area. The area was 400 newtons. No, the force, 400 newtons. Then the area we have just calculated is this one. So you substitute where there is the area down here. And when you divide, your answer becomes, which figure is this? It is a 4 million. 4 million, what is the unit for pressure? It is either pascals or newtons per meters squared. How many marks were given here? There were 4 marks. So we shall give you a mark for changing the unit for area from centimeter squared, and this is what the examiner was testing you to see. Are you going to use this area like this, or you are going to change it to SI unit? So we shall award you marks for changing correctly the units of area from centimeter squared to the SI unit. Then we go ahead and now award you marks for formula for pressure, substitution for pressure, the correct answer for pressure, and the correct what? Unit for pressure. You see? So this question was a bit technical. The examiner wants to know whether you can change units from one form to another. Now let's look at question 4. This one talks about atmospheric pressure, which is really about pressure. The atmospheric pressure of a certain place. The atmospheric pressure of a certain place is 100,000 pascals. If it causes a force of 1 million newtons, that is the force, find the area over which the atmospheric pressure acted. You see, so they want the area. So here they have given us the force. So as part of our solution, we shall say force is already given as 1 million newtons. The pressure is also given as 100,000 pascals. And this particular examiner wants the area, which is under question mark. So we shall go for our formula. Pressure equals force over area. If there are 2 marks, a half a mark goes for that formula. Then substituting, where there is a pressure, you see pressure is here, you write 100,000. Where there is a force, the force is here is 1 million. You write 1 million here. Then divide by area which you want. Then you now cross multiply. Cross multiplying means A will multiply 100,000. A times 100,000. Then 1 million is supposed to multiply something down here, and it is not there. So we consider it as 1. And that 1 times 1 million remains 1 million. So because you are interested in A, what do? You divide both sides by 100,000 so that this one's cancel. And mathematics says when you divide this side by 100,000, you also divide the other side by 100,000. You divide both sides. So this 100,000 will cancel this one. You remain here with the A, which is our area. Then when you divide 1 million by 100,000, the zeros cancel, your answer will remain 10. The SI unit of area is not centimeters squared, but meters squared. So out of the 2 marks, I have for the formula, I have for the substitution, I have a mark for the correct answer, which is 10, and then the remaining half is for the unit, which is meters squared. And you get all your marks. Now, let's look at applications of pressure in solids. You know, we are talking about pressure in solids. And we said there are 2 factors which affect pressure in solids. What did we say? Force and area. And I remember giving an example when a doctor is injecting somebody. You see, he applies the force at the end of the needle. Why? So that the medicine can move, you know. So where do we apply pressure in solids? 1, do you know the reason why when you are going to slaughter your chicken, you have to make sure that a knife must be very sharp? The part which is supposed to cut the chicken must be very sharp. Very sharp means what? The area should be big or small. The area which is supposed to touch the chicken or cut the chicken must be too small. Why? Because we already said when the area is small, the pressure is high. And when the pressure is high, it means the knife will cut very fast. So we have applications of pressure in solids. Where do we use pressure in solids? Knowledge of pressure in solids. 1, sharp needles easily penetrate the skin. I think that is very clear. When the doctors are injecting, you realize that the part of the needle which is supposed to touch your body must be too small. Too small means the area is small and therefore it is sharp. Sharp needles easily penetrate the skin. Why? Because the area is small. When it is sharp, it means the area is small and therefore the pressure is what? High. So, I've just talked about this one. A sharp knife cuts much more easily than a blunt one. You see, if you have two knives and one is sharp, one is blunt, the one which is sharp will cut. You know, sharp here means the area is small, the area in contact, the area which is going to touch. For example, if it is a knife, the part which is supposed to cut the mango or the pineapple should be very small. Why? Because when it is small, it is sharp. And when it is small, the area is also small. And once the area is small, the pressure is high. And therefore, the knife will cut faster. And we are giving a reason here that this is because the surface area of the blade is very small. Hence, it exerts high pressure. The reason why a sharp needle cuts faster and more easily than a blunt one is because the area of the blade is that part which cuts. The area of the surface area of the blade is very small, and therefore it exerts high pressure. Therefore, it exerts high pressure. This is what we said, that when the area is small, the pressure is high. And when the pressure is high, the area is small. Is that okay? Now, let us look at a question here. Let's look at a question here related to what we have just talked about. And the question is, explain why it is more painful. You see? Explain why it is more painful. Let me bring it closer. Explain why it is more painful when you are pricked with a needle than a nail. By the way, when you are pricked with a nail or the needle, you feel pain. But where do you feel more pain? You feel more pain when you are pricked with a needle than when you are pricked with a nail. And the examiner is asking you why. He has already told you. He knows very well that when you are pricked with the two, you feel more pain with a needle than the nail. Now, his point here is, what he wants from you is to explain why. Why do you feel more pain when you are pricked with a needle than when you are pricked with a nail? So you have to compare the two. So you say, the area in contact when pricked with a needle is smaller than the area of the nail in contact with the human body. You see? When you look at the needle and the nail, which one has a smaller area? It is the needle. So we are comparing the area. So we are saying the area of the needle is smaller than the area of the nail in contact with the human body. So what does that mean? Since the needle has a small surface area, it exerts high pressure, which ends up with more pain, resulting to more pain. However, a nail has a bigger surface area. And once the surface area is big, what happens? It exerts low pressure, making the pain to be less. Now, we are given here 3 marks. I want you to know how to answer questions. You see? So what did we say here? The first thing here we compared. The examiner wants you to compare a needle with a nail. Don't talk about a nail and forget the needle. And don't talk about the needle and forget the nail. He wants you to compare the two as you are busy explaining. So the first thing, tell the examiner that the area of the surface area of the needle is smaller than the surface area of the nail. And then go ahead and tell him, because the needle has a small surface area, it exerts high pressure. And that high pressure results into more pain. Then for a nail, it has a big surface area. And therefore, it exerts low pressure, making the person to feel less pain. Now we are looking at pressure in liquids. We have already talked about pressure in solids. Is it true that liquids also exert pressure? You might have heard people say, today the pressure is very high. The pressure of the water coming from the tap. Yesterday the pressure was low. What does that mean? It means liquids also exert pressure. Now, there are three states of matter. We have the solids, the liquids, and the gases. We have already talked about pressure in solids rather. So now we are saying liquids and gases also exert pressure. You know, air, which is an example of a gas, and any other liquid like water. Liquids and air also exert pressure. That's why people say today the pressure of water is high from the taps. Yesterday it was low, meaning that pressure is also there in liquids and even gases. Now, we have one word, this word here, fluids. This word is used to mean two things, liquids and gases. So, we have said liquids and gases or air also exert pressure. Those are liquids and gases, are called fluids. So we are talking about pressure in fluids, pressure in liquids and pressure in gases. But we are beginning with pressure in liquids. Now, when we were talking about pressure in solids, we use the formula pressure equals force over area. And we said the factors which affect pressure in solids are, you get them from the formula. That is force and area. Now, can we say the way you calculate pressure in solids is the same way you calculate pressure in liquids? No. When you're calculating pressure in liquids, the formula is this. Pressure is equal to, P means pressure, H is equal to height or depth. The word depth comes from the word deep, because the liquid could be in a container, or it could be water in a dam. So this is the height of the water, the height of the liquid. Then this symbol is in a certain language. And in that language, this symbol is called rho. The spelling for rho is R-H-O. For them in their language, this symbol means what? Rho. But here in this formula, this symbol means density. So density rho, you see, you write as if you are writing a P, but it's not a P, you see? Do like this, you bend like this, and then you do this. It is not P. So that is rho. So, but it is representing density. So pressure is equal to H rho G. What does H represent? Height or depth. How deep is that liquid? If it is water, how deep is it? Then the density of that liquid. In senior 1, we taught you about densities. That every liquid has its own density. The density of water is different from the density of paraffin. Both of them are liquids, but each one has its own density. So, to calculate pressure in liquids or gases, you use the formula P is equal to H rho G. P means pressure. You see, I've already put them here. P means pressure. What is the SI unit of pressure? It is newtons per meters squared. Then H means the height. H means the height. You either say height or depth. Depth comes from the word deep. The depth of that liquid. And then G, right from senior 1. We have not finished rho. Rho, that is the density of the liquid. The SI unit of density is kilograms per meters cubed. You see, this is pressure in SI unit. The height, what is the SI unit of height? Height is the same as the distance or length. The SI unit of length is meters. Then rho is density. The SI unit of density is kilograms per meters cubed. And as I was hurrying to talk about G, we all know G. G means acceleration due to gravity. Now, acceleration due to gravity, we use letter G, small g, to represent it. But the value of acceleration due to gravity is 9.8. But it has been rounded to make 10. So sometimes you can use 10, sometimes you use 9.8. Sometimes the examiner can even trick you by giving you 9.81. So you use the one you have been given. But if you have not been given, then you use 10. So G represents acceleration due to gravity. Now let me pose a simple question. By looking at this formula of pressure in liquids, what are the factors which affect pressure in liquids? Automatically, there are three factors there. You see, pressure is affected by height of the liquid, density of the liquid, and then acceleration due to gravity. Now, this acceleration due to gravity is constant. And because it is a constant, we always don't talk about it. The density of the liquid can keep on changing. The height of the liquid can keep on changing, making pressure also to keep on changing. But acceleration due to gravity does not change, especially on Earth here. So for that reason, we normally talk about two factors affecting pressure in liquids. That is the depth and density. So now let's move on. And I think that one takes us to the next question. The next question is now talking about factors. State the factors affecting pressure in liquids. State the factors affecting pressure in liquids. And the answers are here from the formula. The first one is height of the liquid. The next one is the density of the liquid. We always don't talk much about this because the value of the acceleration due to gravity is always constant. So there are two factors which affect pressure in liquids. What are they? The first one is what? The depth of the liquid, you see, and then the density of the liquids. So if there are two marks, one is for the depth, you either say depth or you say height, then the density of the liquid, and you get all your marks. Okay? Now, using that equation, I want us to try, you see, using that equation, I want us to try to do some calculation. Let us see how we can calculate pressure in liquids. That is part B. Find the pressure exerted by a liquid. If they had said find the pressure exerted by a solid, the formula would be force over area. Pressure is force over area. But here it is a liquid. And if it is a liquid, then you should always remember this formula, that pressure in liquids is equal to height times the density of the liquid times acceleration due to gravity. So let's move on and see how we can handle this. Find the pressure exerted by a liquid, okay? Roman 1, at a height of 2 meters and a density 1000 kilograms per meters cubed. So they want us to calculate pressure and it is in liquid. So we write our formula. Pressure is equal to H times density rho times G. Height times density times acceleration due to gravity. Now the question is calculate the pressure. So the pressure is under question mark. But here in Roman 1 we are given the height. H is given as 2 meters. The SI unit of H is meters. So if this was given in centimeters or any other units, you first change it to meters, but it's already in meters. Remember, to take you back, what did we say? That if our pressure after calculating should be in what? Newtons per meter squared. The height should be in what? Meters. The density must be in kilograms per meters cubed, you see? So let us see how we are given here. Our density is given, you see, the density is here. It's already in kilograms per meters cubed. So our density rho is already in kilograms per meters cubed. Then our height is here, 2 meters. Then the acceleration due to gravity has not been mentioned. That means you can use what? 10 meters per second squared. Then you use your formula. Pressure in liquids is equal to height, which is 2. This is 2 here, times the density. This is density rho. It is 1000. Times acceleration due to gravity, which were not given. Do you know why they did not give us? Because they know you know it. They are aware that you know it. When they want you to use 10, use 10. If they want you to use 9.8, use 9.8. But when they don't give you, it means you use 10. So use here 10. And when you multiply all this, you end up with the 20,000. The SI unit of pressure is newtons per meter squared. Now, in case there were 2 marks to be given, a half would be for the formula, another half would be for the substitution, another half would be for the correct answer, and then another half for the correct unit. So you get all your marks. This was part A. B, part A. But we still have also, not part A, this is B, this is B Roman 1. Now let's look at B Roman 2. We are given the density. Here the density is different. Is what? 13,600 kilograms per meter cubed. And then the depth is in what? Centimeters. So what do? We must change this depth to meters. So we shall say pressure is what the examiner wants. You see? But the density, you see the question is still there. Find the pressure exerted by a liquid. In Roman 2, the density is here. So our density rho is 13,600 kilograms per meters cubed. Then the height is here, 12 centimeters. So our H here is 12 centimeters. So as I said, the SI unit of density is correct. It is this one. But the SI unit of height is not centimeters, but meters. So what do? We change centimeters into meters. How do we change centimeters into meters? We divide by 100. Why do we divide by 100? Because 1 meter is equal to 100 centimeters. So whenever you're changing centimeters to meters, you should divide it by 100, you see? So this arrow is reminding you, showing you that much as we were given the height in centimeters, you are supposed to change these centimeters into SI unit. The SI unit of distance or height is not centimeters, but meters. So you get the 12 centimeters divided by 100. And you get 0.12. These are now meters. After changing the centimeters into meters, you can now use them in the formula. Pressure in liquid is equal to H times density rho times acceleration due to gravity 10. The height is now this one, the one in meters. This one you don't use it again. You have already changed this into meters. So you use that, the one in meters, times the density which you were given here. This time the density is what? 13,600. Times the acceleration due to gravity which you were not given. Why? Because they are aware that you know it.